Hello and welcome everyone to the Unified Observability in Grafana with Converged Oracle Database Lab. My name is Kara Van Cleve and I'm a marketing event manager for the developer initiative here at Oracle. Today we're excited to show you how to automatically configure and use Unified Observability in Grafana to analyze and correlate metrics, logs, and tracing. If you do not currently have an Oracle Cloud account, we encourage you to create one now. A free account link with access to the always free as well as cloud trial services, including a special promo, has been placed in both the Zoom chat and the Slack channel, and I'll post these links again shortly for anyone that's just joining. Please use the same email address to sign up that you registered with for the workshop today to claim the special offer. We'll be recording today's session, so if you'd like to follow along with the lab walkthrough and then complete the lab later on at your own pace, we'll be sending the link to the recording via email shortly after the webinar concludes. You'll also have the opportunity to participate in a short quiz on the material covered in today's lab. Upon completing the quiz, you'll receive a developer masterclass badge that you can share to your social media, recognizing your commitment and earned expertise. If you have any questions during the workshop, please ask them in the Slack channel and we'll answer them throughout the session. The link to join is bit.ly/devrel_Slack. And once you're in, you'll land in the general channel. And from there, you can search for #Oracle-DB-microservices to reach our dedicated space for Q&A today. We will also have the Q&A function of Zoom available and the chat as well. Today's workshop will be presented by Paul Parkinson, architect and developer advocate for microservices with Oracle Database. So without further ado, I will turn it over to Paul.
All right, thank you, Tara. I will go ahead and share my screen here. Okay, this is just a little 3D room the XR lab made to give you a lay of the land here. You can actually go in here if you want with a VR headset, but I'm just popping in here to mention our agenda for today. So I'm super excited. This is the workshop I've wanted to give for a while now. And I appreciate everyone that signed up for the first time. We had to reschedule, and if you're in the States, today's a holiday as well. So really appreciate everyone that's coming out because I've been working on this and really excited about this topic in general. So this is our agenda. I'm going to give a even less than 5-minute overview of the workshop, and then it's a 5 or 6 minute walkthrough to set up the lab one. So that'll give you the architecture and everything. I'll talk about that. Then while you're waiting for the setup to complete, all the provisioning, I'll give a presentation. It's about 30 minutes long. The actual provisioning doesn't take 30 minutes, but really what we'd like to get done today is to get the concepts across to you and to get the workshop set up for you. And ideally get you through the first 3 workshops, basically, or first 3 labs in the workshop, because that will set up your environment, and then you can take that away later and play with things, because the number of use cases for observability is just infinite. So that's the main goal today. And then like as I say, we'll do the actual workshop walkthrough. And so with that, I'm going to ask a poll now, if you don't mind. Just asking if you plan to actually do the lab or just watch and do it later. And there's no shame in in the latter option because again, there's a lot of concepts, and since you have this at your disposal for later on, that's completely valid. So you can do it now with us, and you can just do it later. So I'll just leave this up for 20 more seconds. And yeah, we see this a lot. This is in 2022. I'm the same way. You attend something and then look at it deeper later, so that you can pay attention and retain it now. And that's overwhelmingly what it seems like everyone is saying now. So so that's great. It won't be tedious workshop steps. It'll be a lot of concepts, and the workshop steps will be, feeding into the concepts. You'll see how to set up Grafana and things like that. Okay, great. Thank you for answering that. So now I'll go ahead and do this quick overview of the workshop. So I will pop over to the slides here. Again, this is the agenda. Start with this 2 slides just to set you up. So the application that is used in this workshop and also in the is the same application that's used in the Simplifying Microservices workshop. And that's kind of our flagship workshop, if you will. That shows a number of different concepts of microservices. So I really encourage you to check that out because it'll describe everything that's on this slide. And I don't have time to, of course, go into that because we're focused on observability. But really encourage you to check that out. And we're using the same application here, which is a fictitious company, GrabDish, an online store food delivery application. And it shows off the Converged database that I'll talk about a bit more in the presentation. But just to give you an idea of the general flow, you have a front-end service, JavaScript service. It calls into an order service in the Kubernetes cluster. That order service goes into an order database where it inserts an order and sends a message requesting an inventory status for the item in that order. And that message is picked up by the inventory service. It shows .NET here, but that's because we've written it in a number of different languages. So that's your option. In this workshop, we just use Java, but you can use .NET Go, JavaScript, Python, all of those languages. So that the inventory service picks up that order request and checks the inventory for that item, sends the response back, whether it exists or doesn't exist. For our case, we're just using this to drive observability. So it'll always just say that it doesn't exist. That's, we're not testing that aspect. We're just testing traffic. That returns to the order service. That message about the inventory returns to the order service. And then that returns to the front end. And so that's the basic flow going on. And we'll show metrics, logs, and tracing in that flow. And we will do that with what the topic is for today, this unified observability design, where you'll be able to see the metrics, logs, and tracing, which I'll probably say those 3 words about 100 times during this presentation. You'll see those through the app and the database tier. So the full DevOps, simplicity and power of DevOps is what we're trying to, what we are showing here in a single console, okay? And so, of course, I'm going to be elaborating on these concepts, and it applies to all the use cases mentioned here. And so with that, let's knock out this this first lab. Again, even if you're, I think it's worthwhile to try and do the setup now, because then you'll be ready later. This is a 5 or 6 minutes I go through here. So even if you're not doing that, just bear with me for 5 or 6 minutes. You'll get the idea of the setup if you want to do it later, of course, as well. And we have a bunch of people from the team on the call here, Rena from the Maximum Availability Group, Paulo and Mark, my colleagues, my fellow developer evangelists, and Sanjay, the boss, the VP for database messaging and microservices. And so with that, I will pop over. I have a little walkthrough video of the first lab. And as you can see here, it's only about 6 minutes long, okay? So let me go ahead and play that, and I'll talk over it and pause, if need be. So I'm just on the left-hand side, there's documentation, and on the right-hand side, the cloud console. So the first thing you've done is logged into your free tier cloud console. That's pretty basic. This is just saying make sure you're in your home region, which you will be by default. And then if you're using free trial, don't worry about task 3. But if you're using your own tenancy, you just want to check that you have the quota to set up these different resources that we're going to set up. And so, we're setting OKE, all the things in that diagram, we're setting up OKE, the databases, etc. Then go ahead and launch the Cloud Shell. If you're not familiar, Cloud Shell is a very handy in-console shell. And it sets up the environment for you to access all the cloud services and things like that. So it's very handy, and particularly for workshop, and you can leave and come back. And this whole workshop can be done in the browser. So it's very nice. So go ahead and just, as it says, create an arbitrarily named folder. That's going to store the workshop source. And what's great about this too is you're cloning source from this repo that you'll see in a second. And so if you want, you can just go directly to this GitHub repo. This is all open source, of course, and just check out, there's a lot, all of our workshops are stored in this same repo. So there's a lot of information in this repo. I encourage you to check it out. And everything from this workshop, of course, is in that repo as well. So all we're doing here is cloning it. We spent a lot of time, simplifying this setup and making it, hardening the experience. And then we'll go ahead after that's complete and start the setup. And so you just issue this command to do the setup. And what's nice about this is the Cloud Shell, intentionally will time out. If it's not used, if you leave the browser, obviously it's going to, but if you don't use the Cloud Shell for a period of time, of course, for security, et cetera, it times out. But the workshop is set up so that when you come back, it drops you right into the workshop again. So you can pick up whenever. You don't have to worry about, reinitializing or anything like that. And, that's what that says there. The amount of time it takes to complete varies. It should actually be less than 20 minutes and for this setup. When I tried it, I just tried it a couple of days ago. And it was much less than 20 minutes, but something like that. Okay. And then that's about it. I'm sorry. And then there are a couple prompts. And so these prompts are just take the default. This is saying if you brought your own tenancy to use this, you could pick the compartment you want it deployed in. So compartment's a logical part of your tenancy. But if you're just doing the free trial, just hit the defaults for this, and that'll be fine. Yeah, as it says, if you'd like to create a new compartment, you can give it the name. And so I just specify, grab dish compartment, any name you want to create that compartment. The next thing you'll do is just take the default for the root compartment that you're putting it in. Again, if you're using free trial, you can just take the default. It'll wait for that compartment to become active. And then you'll enter your user's OCID, okay? And so you can find this a few different ways. The easiest way to do it is to go to the upper right-hand corner where your profile is and just click your profile. That'll bring you to a screen with your profile information where you can then go ahead and just copy that OCID, and drop it into for the prompt in the Cloud Shell there. This will create, just for your information, this behind the scenes creates an auth token for access to the OCIR repo. That's where you'll keep your images for the microservices. So again, this is setting up a Kubernetes cluster, the OCIR image repo, 2 PDBs, 2 lightweight Oracle databases. So we have this, I'll talk about this in a moment, this nice decoupled microservice architecture, and the load balancers and things like that, okay? And the only thing left to do is enter the password for the database and the password for the UI for the front end service. And so that's what you saw there, okay? Then you could just monitor the setup. You simply, if you leave, fire off the setup, and then just leave and come back the next day or whatever, you can just issue the command status that you see here, and it'll say, where you left off. So it's nice. You don't have to worry about anything. You just do that. Okay. And so with that, I'm going to go back to the presentation. Again, if you have any questions on that, the people I mentioned in particular are extremely familiar with this setup. So please feel free to ask any questions. And I really encourage you to contact us in any form, but the Slack channel is a great way to find us. Other people may hit, if you hit an issue, they may hit the same thing. And, we can talk about whatever topics, but feel free to, Twitter, LinkedIn, or whatever, contact me with any questions on any of this and any use cases you'd like to see. We're very eager to, say, I want this for my observability, and I'll go ahead and, implement it for you and show it in this solution we're talking about. Feel free. I will work for, your use case. Okay, so with that, let's go back to the presentation on unified observability. So first thing I want to talk about that kind of makes all this possible and makes it even more robust is the converged Oracle database architecture. So what we're talking about when we say converged is the fact that it has so much functionality in one database. In a word, it's all these different data types. So as you'll even see in this application we're using JSON, traditional, relational, spatial, using ML, different workload types, and they're all within the same database. So you get this converged solution, and you can even access this through, you're accessing it through all those languages I mentioned earlier. It's open in that sense. It's accessible through all these CNCF technologies you see on the left here, but it even has compatibility with other vendor APIs such as Kafka and Mongo. So you can use Kafka and Mongo APIs to access the database. So that's what we mean by converged. But at the same time, it's lightweight because the database is, it's perfect for microservices because you can divide it along what's called a portable database or pluggable database, PDB. And so you get that bounded context separation that you would using individual databases, but you don't need to use, Mongo for your JSON and, Postgres for your relational. You can do that within the same database. And so it's just, this is, a whole other presentation, but it really is awesome because you get all the administration, HA, and all that consolidated and converged. And the other kind of cool thing is, the other very cool thing is, it actually provides additional use cases. So you can have a query that does, ML, GeoJSON, and, spatial whatever queries, ML, even ML in the database, in one query against the same database. And you're not doing mid-tier joins and things like that, just nightmare stuff for microservices. So anyway, these are some of the strengths of converged Oracle database. And again, this is the application that we're using. Once this first lab is complete, all of this infrastructure is set up, and we simply hit one command to deploy all the microservices on it. Okay, so we have the PDB separation, both examples of PDB separation and schema separation for our microservices. The event-driven communication, which we have observability and tracing over that. Different languages, different data types, and transactional patterns and things like that. So a lot in this application. It's a good one to use for tracing. And then what we're talking about today, the unified observability design. We'll be showing you in the workshop the end-to-end metrics, logs, and tracing from the app into the database. I'm going to elaborate on this. It's it's a complete flow. So for your DevOps, you're not going from console to console, for one console for observing logs, one console for observing logs in Kubernetes, one for observing it in the database, and the same for metrics and tracing, and how customizable it is. This is the open source repo where we keep the source for all the exporters, which I'll talk more about. And in the next week or so, we'll have the actual container in the public repo for you to access. So this is what unified observability looks like in the Grafana console, just quickly. And this is what you'll see in the workshop, exactly this. These are screenshots from the workshop. And from right to left, it's metrics, logs, and tracing. And you'll see, so it's one console. This is our GrabDish application in one console showing all this information. So just quick screenshots that I'll elaborate more on, of course. And so I was going to start with why observability, but probably if you're on this call, you know why observability. Especially with microservices, it's just completely necessary. And the question is, what to use, what's the best thing for observability. So I go right into why OpenTelemetry, why use the standard. But before I do, I'm going to ask one more poll question, if you don't mind, to kind of gauge, who is attending here, to maybe get a slightly better idea of, what you're looking for, where you're coming from. So if you don't mind, I'll pop up another poll. And that is to ask you your current role. So if you don't mind answering that, I presume I was also going to ask, what's your experience with observability, but I think, we're going to kind of go from the beginning to the end anyway. So I think it's more important what your actual role is, what you're trying to get from it. And these results are very valuable to us, so appreciate it. And I'll just leave this up for another 20 seconds or so. But as it stands, it's looking like at least half DBAs, which is great. And then DevOps engineers, of course, architect and data engineers. Okay. Yep. And less of developers, CTOs, and data scientists, but the data engineers and DBAs. Yeah. Okay, excellent. Yep, because this is a, it's certainly developers, and DevOps, half of the word DevOps is developers, of course, right? But this is obviously DevOps topic. And these tools, help developers. Okay, thank you so much for that. So why OpenTelemetry? OpenTelemetry was started back in 2018 or 2019, maybe 2019. And we all saw it developing and things like that, but this past year or so, you can really see the fact that it's great that it has become officially used. And you could see that before this survey from CNCF came out, but this makes it very plainly obvious that OpenTelemetry is the focus. So we've all been using these standards. And let me get right into the definition of that. So OpenTelemetry is a collection of tools, APIs, and SDKs. You use it to instrument, generate, collect, and export telemetry data, metrics, logs, and tracing. So we've all been doing this. OpenTelemetry, skipping down to the second point here, the main goal was to consolidate these standards and increase automation. So there was less need for code changes and things like that. So moving down to metrics, Open Metrics is strikingly similar to the Prometheus format. Obviously that's intentional. And likewise for tracing with Jaeger and Open Tracing that came before it, it's all fully compatible. And then logs, that's why I love the three pillars. They each have their special thing to them, but logs has been around for so long that that's more of a kept general as far as the specification, because log formats go back for decades and decades, right? But to have this kind of umbrella standard is great for adaptability and pluggability, and it facilitates this additional goal of reducing the need for app code changes, which is great because that's been a barrier, especially for bringing legacy apps into microservices and things like that. The need to go into code and change it is a real barrier. So the fact that OpenTelemetry is providing solutions for this has been a big one. And as I've been saying, it's essential for the design around microservice architectures. So then the next question, why Grafana? So I imagine most of you have heard of Grafana. It's just, it's so widespread and so well done, and such an open standard that it's no surprise that it's been widely adopted. And I I love this tool, Grafana. There's like so much you can do with it. But it's lightweight, and it's an open source alternative to some of these and these other like Elasticsearch, Splunk, etc. But I don't want to say that they're mutually exclusive or anything or that other Oracle monitoring tools like EM and APM and things like that. It's not like necessarily one or the other. But we're talking about this unified observability where you want to all those use cases, like debug something, do performance analysis, and see the big picture, and do that in one console without, literally, I know a lot of the use cases. Okay, this happened over here, and here's the timestamp. Let me see what the timestamp was in this console. That's crazy. And so we're always looking for the hardest problems in modern app dev and microservices, like transactions and data and observability, and trying to focus on them. And so that's what we're doing here. And so Grafana, we're using a lot of Grafana features, they're Grafana's features, but then facilitating them with the Oracle database to get the most out of them. And that's what I'll go into more with the exporters that Grafana's picking up and all. So and of course it just has all of the built-in support for all these various open standards. I just happen to put Prometheus Alert Manager because if you notice, more and more, and Grafana 9 just came out like a week or two ago, they are really adapting it to provide what exists in other products and layers. So if you look at their alert, Grafana alerting, it's very much like Prometheus Alert Manager. It's not a secret. They're obviously they're doing that, but they're doing their own kind of innovations to it as well. So the Alert Manager, and we see a bit of that today, and they've done even more in 9. You see they're really putting a lot of focus on that. It's made so you can use this Grafana tool. And again, this gets into different use cases and things like that. So a lot of people will use the Alert Manager on their local region, say, and then that feeds into Grafana, and then they use Grafana Alert Manager for like overall aggregate type alerts and things like that. So there are a lot of different combinations, but the Grafana bringing it all into this single pane of glass view is, really fantastic. Yeah, and it, uses PromQL and things like that. So it's well suited for all these fleet cross-region, and it's multi-cloud and portable, of course, which is, that's so key to so many architectures, whatever the cloud may be, it's, portable. And of course, it's cloud native open standards based with a huge community. And so then that leads us to why Oracle Unified Observability. So as I mentioned, you want the ability to get this information across the app and database tiers. So it's not this disjointed observability experience. You get the full flow, metrics, logs, and tracing across the 2 tiers and all the correlation. What's very unique about the Oracle database solution is you can really customize these queries. So you have any SQL query you can use for all 3 of these. And so that's where you can really get into aspects where, just jumping ahead a little, if you're familiar with Oracle database, alert logs or trace logs, basically, database logs, you can query for just specific information on that log and combine it with some other, arbitrary or, related information, and then log that. So you're doing custom logging. So you're not just like dumping log files. You can put intelligence into it, and very easily, because you're using these long developed, long used SQL PL SQL. So when I'm developing these, I'll just, search around for, top 10 queries, Oracle queries that I've used for observability. So there's a wealth of that information out there, and then bring it into this, and you get the full picture and these robust queries. It's just, a great combination. And then you get all the stuff you inherit. So you get this secure access through the database. It's one access through the front end. So for example, with logs, you don't have to go directly to the logs, the backend log access, which in cloud environments, that's secure environments in general, and cloud environments that may not be maybe a non-starter. So to be able to go through the front end, not just the querying capability, but the unified secure access is nice. Tracing into the database. So this is very unique for Oracle. Usually you're coming up to the edge of the database and that's where it ends. You might have your SQL statement text because you can get that off the client, but you're not getting any information, on inside the database that you're correlating out in one console. And so that's an advantage of this unified observability, is that you can do that. You can go into the database, what's this sort SQL statements binding values, bound values, what stored procedure, what is the trace of that? The stored procedure called this stored procedure that went here, then went here, things like that. The messaging in our database, that's a whole other presentation, but super strong support for messaging in the database that's transactional and been around for decades. You get the tracing of that included. So it's the whole communication and data. You can do the SQL query of what SQL statement's taking the most CPU and get it down to the single request layer, just on and on. It's something so powerful to be able to go into the database. And, again, it's from your front end, it's from your mobile device into what SQL statement took the most CPU or whatever, like I'm saying here, in the database. So complete end-to-end tracing. Advanced security and auditing, of course, data safe and things like that in the database you can even use. And it inherits all the Oracle goodness as far as HA and things like that. And this applies to all the Oracle database types. So this is for all of them. And that includes in container, in Kubernetes cluster. So, data on Kubernetes, use cases. So any database that you're using. But it's not limited to the Kubernetes environments. You can run these exporters and such outside of Kubernetes as well if you want. And some customers do. Simple setup, I'll talk a little bit about the Oracle Database Operator. So we're putting out an observability controller in that operator. And so literally in one custom resource definition, one Kubernetes YAML file, you say provision a database and set up all this observability for that database, and boom, it's that simple. Then you have a database and you're all set up to monitor with all of everything I'm talking about here. And so of course that works well with CI/CD, both the operator and this observability, and it's multi-cloud, as I mentioned. So I'm going to go through the exporters one by one, starting with the metrics exporter. So as I mentioned, all of these have customizable queries, and you can run them that are run against the database, and then they're translated into Open Metrics Prometheus format. And then Prometheus comes around and scrapes the exporter for them, which then feeds into Grafana as a data source, okay? And so a very simple example of the configuration for the metrics exporter is shown here. You have a context, a description, and then a request. And if you're familiar with Prometheus, this is the mapping you're giving for labels as well. So you're doing whatever request, and it just maps into total subscribers in this case. But again, any request you want, and it maps that information to be scraped. And I'm mentioning these distinctly, the metrics, logs, and tracing exporter, but they're all part of the same exporter image. And so you can, run metrics, logs, and tracing, any combination of these. In other words, it's one controller in the operator, if you're using the operator, but it's one actual observability exporter that's doing these three. I just list them separately. For the log exporter, again, you have these customizable queries, and these are then logged, and then they're scraped and pushed by Promtail to Grafana Loki store, and then presented in Grafana. And I'll show you in the workshop all the features that Grafana has with Loki as far as correlation and things like that. And so in an example of a configuration for the log exporter is shown here, where it's, these are all extremely simple examples that I've put here. But, you have a request to get certain fields out of the alert logs. And again, you can, whatever view you want to use, whatever joins, etc. And then just the timestamp field to show what your filtering is. So you're logging incrementally, you're not logging the same thing over again. And so that's the architecture for that. And then finally, the tracing exporter. This is, as I say, I like how each of these pillars have their own special aspect. And again, people do different things. Some people are of the mind where they just log everything, they even log the tracing information. And then they build up the traces from the log. And that's okay as well. The solution completely works for that. But tracing is unique because it involves the actual flow through applications. And so before I talk about the exporter, let me talk about backup and talk about the full solution and architectural flow of tracing that we're providing. So there are really three main components, but optionally four, and the fourth being this tracing agent. So the first component is your app, of course, and it's conducting database operations into the database. And in one way or another, it's doing tracing, Jaeger, OpenTelemetry tracing. And so it's either explicitly using a library to add the ECID here to it when it makes a request to the database. It's put in the database session with all the other app context information, language and things like that. Or you can have a tracing agent. And this, I'm showing Java here, and Java is, of course, probably the most robust of the languages, but these tracing agents in one form or another exist in other languages as well. And what they do is, in the case of Java, for example, it's bytecode manipulation. So you attach this agent, and the agent says, whenever there's a call to the database, add this ECID identifier to that request. And so you're able to obtain that goal of OpenTelemetry where the user does not have to modify his app source whatsoever. So you have a 20-year-old legacy app, you can use this, and so that's the first part. The context is flowed to the database. The second part is this tracing exporter. I'm sorry, so the application is passing this to the database. The application is also sending its information about the trace to a trace collector, such as Jaeger, okay? And again, that can be done without code modification. The call is made to the database. The second part is the trace exporter, which is querying the database for those identifiers. And as I say, currently we're reusing the execution context ID, the ECID, and in future versions, we're developing actively in this space. So we're doing a lot in the database as far as convenience, instrumentation, APIs, and things like that. But the ECID is being reused now. We'll have a new span context ID that can be used in the future. That is queried for, that ID, whatever it is queried on by the tracing exporter. And that tracing exporter, just like the other exporters, it's translating that into a trace span. And it's sending that to the tracing collector. And of course, it's the same trace ID. So the trace collector is combining that, sending it to Grafana, and that's how you're getting this, app into the database tracing information, end to end. That's how that's achieved. So it's very, very nice architecture because, again, obviously you're not manipulating the database to do this. You're not manipulating your app, and yet you're getting a trace across the two of them through this architecture. And so similar to the others, you have your trace exporter. You can provide it any SQL query you want. You can customize it. And you can say what information you want tagged to your trace. So, I want ECID, SQL ID. This is extremely simple here, but you can have, as I say, the bind values, anything that's you're able to access in the database, you can add to your trace. And so this, the DevOps person doesn't need to dig into the database per se. It's in this single thing. And of course, with all of this, best practices as far as security apply, right? You want your user to be this not to be open to the world. You want a user that has specific permissions. You want to make sure you're not logging sensitive information and things like that. There's nothing better or worse about this solution as far as security aspects and observability. Yep, and again, just to go back quickly to the Converged database, it's nice because, you know, this query, as I say, you can be doing this in JSON or whatever. You can be returning these values. Whatever you can execute against the database, you can put in here. So, you know, very extensible. And so here's an example. This is actually in the Jaeger UI. I should show you this in Grafana, but it looks exactly the same in Grafana. This is an example trace where it came in from the front end into the database. I explicitly called this child added by trace exporter. And then, you know, you can additionally nest within the database spans in that trace. And so here you see, I just always resort to a very simple case, which is the binded values, because that's something that's just black and white. You can't get that from the client. So here I show the fact that your trace actually has a bound value of that SQL call. And again, you can see this in Grafana. This is just, we're focusing a lot on a number of things, but we're focusing a lot on the financial vertical and also on mobile solutions. And so the tracing solution you see here is for a cloud bank app. Again, in this workshop currently, it's Grabdish and online retail scenario. This is the cloud bank scenario. And you can see, you know, all different from REST across the messaging, across multiple databases with no code changes. You're getting all this tracing information. Okay. And then, you know, I've gone through all of that, but it's also this combination, this unified observability also is, you know, greater than the sum of its parts, because you can then also use features in Grafana, such as the time synchronization between, you know, metrics, logs, and tracing. You can synchronize what you're looking at by time. The trace to log and log to trace features. So I'll show you in the workshop how, you know, you're looking in a log, it will have a Jaeger button. And you click on the Jaeger button and it will take you to the trace that corresponds to that log, and vice versa. So for drill downs, you know, you can see super valuable. Again, it can run in Kubernetes or outside Kubernetes and is part of the observability controller. So with that, I'll talk just a moment about this. If you're not aware, there's an Oracle database operator. So in the Kubernetes space, you know, everything's become an operator to make things simpler. And so we have a Oracle database operator that works for all the different database types. So that is another full presentation, of course, but extremely easy and powerful. And we're adding an observability. So an operator has one or more controllers that do, you know, do different things. Adding an observability controller to that operator that lays down all of the exporters that I've mentioned to you. And it does it very simply with config similar to what you see here, as far as just name the database you want to have observed, do any overrides that you want as far as config and things like that, and then just do, you know, kubectl apply to this, really as small as this file here, and it'll set up all the exporters and things like that for the database that you just provisioned. And provisioning the database in the first place has a simple YAML as this. So, you know, trying to make things powerful and simple. That's, you know, the #1 goal we have here. And I'll come back to this slide, but for more information, these are some links for you, including the source code to this workshop. Okay. And so with that, I'm going to go back to the workshop. So some people have gotten through it. That's great. So you're all set up, and that is what's great about these live labs. You can come back and toy around. Like I say, the next two labs I'm going to walk you through. Let me end that poll. Are what, 3 minutes? That's the basic setup, and then 14 minutes. Now, after we go through this 14-minute, the third lab, you'll get the idea of the setup and be able to take it to your use case. And again, I want to keep reiterating, the Slack channel is the best spot, but any way you can contact us, if you could just be lazy and say, this is the use case I want, can you show me how to do it? And I'm happy to, because, we're interested in the information and fleshing this out and making it more relevant and robust. But we'll give you a couple quick examples of use cases with this. So the first workshop set up all your architecture and things like that. The second workshop is just going to deploy that GrabDish application and do a simple request just to make sure it's working. Okay, so let's just walk through that. This is what we refer to as expressive mouse movements, since it's a silent movie. So the objective, as I said here, is just to deploy it and test it. So you just go ahead, you're in your Cloud Shell again, of course, just go ahead and copy this command. This will deploy the front end, the order, the inventory service that I mentioned are involved in the flow here. And there are a number of shortcut commands in the workshop. They're mostly kubectl commands. But if you ever want an overall command, if you type ms data workshop, all one word, that brings up all the resources, displays all the resources in the workshop, which are the services, secrets, deployments, pods, everything in ms data workshop namespace. So just so you know, there are a number, and that command will also at the bottom, at the end of it, show you the other shortcut commands. So if, I find these commands, convenient. So once that's done, you'll see this output, and you can check the ready state of the pods with the git pods command. And you should see them all running. Generally, the order service is the last one to finish because it has a very conservative liveliness probe to it. But they come up very quickly. Then there's this utility curl pod. This is a BusyBox pod, so that's like a utility. And so what this shortcut command is doing is giving you a pod with a shell in the Kubernetes cluster, so you can make requests within the Kubernetes cluster. So this is just kind of handy. You can, you could use a load balancer as well, and the other workshop does. But this is, you can do curl commands, like I say, directly against resources here. So just replace the value here with the UI password you used during the setup, and this will this command will issue a request for an order that'll put you through the flow that I mentioned earlier. Okay, and so what you'll see here is the output of the order is in pending state. And then the next command we'll do is to say git status. We deliberately show the intermediate state of pending for some transactional things that we do in the other workshop. So then there's an additional command where you can say, give me the status of the order. And that's what we're placing here. That's what we're issuing here. Okay, and then you'll see your output that the order was placed. The inventory didn't exist. That's, that's a successful issuing of the application. It's just showing the inventory doesn't exist. Okay, and so we know the application is working. That's all we did for that lab. Deployed it and verified it was working. Now let's move on to this next 13 minutes and 39 seconds is going to show you the setup you're looking for, basically. So, as far as this unified observability. And, all the correlation and things like that. This is the meat of the workshop, is this lab here. So the first thing we're going to do is install the all the Jaeger, Prometheus, Loki, Promtail, Grafana. And I just put this in a convenient shell script. This workshop isn't about how to install, and it's fairly straightforward anyway. If you look in that shell script, it's just, install, install, install. So there's no need to go through it. So that's what this is doing here. Okay. Now I clip out a little on this. This doesn't take long, but we're not going to sit here for the 2 or 3 minutes, of course, that it takes. And that's about it, maybe 2 or 3 minutes, and they're all installed. Okay. Then the next thing we're going to do is create the monitors and exporters. You may want to look at this shell script later, especially if you're going to be building on this. But what it's basically doing, if you're familiar with Prometheus, for Prometheus, you have your service, your Kubernetes service, and you define a service monitor with labels that match the service. And those service monitors are picked up by Prometheus, and it says, okay, go ahead and scrape this service. And so it's creating those, it's creating the exporter, and it's just issuing the deployment for that exporter. Okay, so you can check that out, but that's not so detailed or complicated per se. So the next thing we will do, that's also installing Grafana, of course. And so we'll go ahead and find out what the information about the service that Grafana was deployed as. So this services shortcut command will show you the services. And so we look at Grafana, we see it's running on that port there. And then you can go ahead and hit that port in your browser. Now this is using a self-signed certificate. So don't be scared by the message. We're just, it's over HTTPS, but we're just using for, dev here, a self-signed certificate. So you just have to accept, you'll get a message like this and say you want to go ahead. This is under your control, so you're not. Okay, and this will bring you to the Grafana console. And so the login here is admin. The password is prom-operator. And the first thing we will do is add our data sources for, for metrics, logs, and tracing for Prometheus, Loki, and Jaeger. So Prometheus is actually pre-configured for you in this case, but we'll just go through it so you see it. This is what you would do if it wasn't. So you go through, your data source, you pick Prometheus, and you provide the URL, and that's for your Prometheus endpoint. You can just go ahead and test it. And then, click back or go back to your data sources in whatever way. Then we're going to go ahead and add Jaeger for the tracing. So you click on add data source and you'll see, so many data sources. Like the community is so strong, so many different data sources, including, Elasticsearch and all of these. It's like I say, it's completely inclusive. It's really awesome how many, and let alone the dashboards. So then go in here and paste in your Jaeger endpoint. If you saw in services that Jaeger endpoint was there, just pop that in and save it. And last but not least, we'll add the logs, the Loki data source. And so same thing, just go ahead and select Loki. provide the service endpoint for that. So, there's not too much to Grafana, but I figured I'd do this, rather than pre-configure it so you can see what's going on here, get an idea if you're not familiar. And then what's unique about what we're going to do with Loki is we're going to define derived fields. And so this is how you go about mapping, enabling that log to trace, trace to log functionality. And so all you're doing here is mapping actual regular expressions from your log to tracing. So the first thing you'll do is pick Jaeger. There's all different combinations of mapping. So we're doing logs to Jaeger. And so we're giving it a name, trace ID from span reported. I should have said from span reported in Kubernetes, just to be clear. But and then we're providing the regular expression that we'll see in the logs, the query type, which is the raw value. And then you can test it using this. And when we test it, we see that we get the URL for the trace from that value in the logs. And that's how it works, just as easy as that. So we're going to do the same thing for the alert logs in the database. So we have correlation of the trace from Kubernetes logs in the app tier and correlation of the trace from database logs in the database tier. And they'll both point to Jaeger, and Jaeger will point back to them for these drill downs that I've been talking about. So it's a great experience, to go in and do this, and you're able to, drill down on this information, say, okay, here's the error, click on the trace, here's where it is in the trace. And then we can go ahead and test this the same way. So we see that works. We're good to go. You can save it. Okay, and then we'll install the Grafana dashboard, okay? And dashboards are, some dashboards are just works of art. They really are, not to go too far, but this is a very basic dashboard I've made, but if you can see, not just visually, the data viz aspect of it is, just fantastic. It's what some people have done. So this is a pretty basic one to show you, especially how you can observe a whole application, a microservices application in one console. Okay, so this is a pre-created dashboard, obviously, and then this is just showing to copy the text and import it into Grafana. And so what I have here, each of these drop downs is a microservice: the front end service, the order service, the inventory service, and then I show the event mesh propagation on the bottom as well. And so what you'll see is it's across tiers, as I've been discussing. So you'll see in the order service there, information, metrics about the Kubernetes order service, and also metrics about the order service on the database side. And so it's all within that section there. So you have the bounded context of each service, and then it's across tiers, and it's all in one single pane. I told you I was going to repeat that over and over again. So, but that, that's the theme here. Okay, and then so what we're going to do here is, do some of that drill down that I've been talking about. And in order to do that, by now, we're only doing one. It's not so similar to real life because we just made one request on our app, right? So you'll probably have to make another request or do a small degree of, in other words, get some data going in the console. So here I just am making another request to the application the same way we did in the previous lab. If you set this up quickly, you wouldn't have to do this, you know what I mean? But or if you decided to, in the Grafana, go back 5 minutes or whatever. That's all I'm doing here, is just getting some fresh data. So I talked over that last part there. So what happened is, just go back a couple of seconds here. Okay, so I made that request. In here, oops, oh no. Back too far, sorry about that. Let me just do this request thing. Okay. So again, just making a request here. In the console, each of those little panels there has a drop-down menu at the top. So where the name of the panel is, there's a drop-down, and it has a number of options. And one of them is to go ahead and explore that metric closer. So that's what we'll see in the next pane here. You select that explore option. So you see that here. Okay, and that's what drilled us down into that particular panel, the metrics of that particular panel. Next thing we're going to do is hit the split button. Little lean on real estate for this demonstration, so I apologize for that. But in Grafana, you can then split it. So side by side, you can compare different data sources, such as what we're doing here with logs on one side, or with metrics on the left side and logs on the right side. And then you click the sync button, the little chain there, and they are synced by time. So anything you're doing on one side is being synced as far as time on the other side. So you go back and forth, you know, very intuitive and nice. And then so on the log side, on the Loki side here, you can select what logs you want to see. And so what we will do is select the logs from the database, which is coming from our exporter, and from the Kubernetes application. And we're doing this for our order service. We'll then go ahead and you may need to refresh the query. And if you can see there, that empty message on the Grafana there. Since I'm doing single requests, again, you just got to make sure the data is there. That's all. So we just hit the refresh button and we see the data. And you'll see the logs for the corresponding metric on the left-hand side at the corresponding time. And in those logs, you can then go down and they're color-coded by, you know, warning, whatever the case may be. So if you go down and see one of these that's in green there and select it, place order is a good one because it's a long trace. You can then see this correlation of the Jaeger link that I was talking about. So that's the very powerful aspect. You got your metrics, you drilled down to the logs. In your logs, you analyzed it and went to the trace. And then here you see the robust aspect of the Oracle database and the messaging engine, where we traced from the front end Kubernetes into the database, into the order service, and traced across the messaging as well. So that's a key aspect, is not just across REST, you know, like the service mesh and things like that have nice features for automatic network and REST communication, but we're also providing this network or our messaging communication. So it went from the front end to the order service to the inventory service and back. So that's a key point, even though I talked through that very quickly, is that you're getting across all communication types end to end into the database. You know, it's just a complete holistic view of it. This is just another, you know, you'll have more than one dashboard. That one dashboard was for your overall application. This is another dashboard where you can see more in depth the actual messaging. And so this is showing us messaging across two databases actually, and information about the queues, the in-queue, DQ rate, things like that. Okay, so just another dashboard. You know, you can do obviously different levels, different use cases with different dashboards. Okay. And so with that, I'm going to go back to the workshop. This time, I'm just going to walk through the actual doc. So again, we're at 1 o'clock Eastern here. If you get through that, you hopefully get the idea of having set up the unified observability, and then you can start to bring your own use cases to bear. Okay, one that's in the workshop is the performance analysis. And so what we do here is we set up an alert and for the response time. And when the alert rule is, if the response time comes below a certain level, send a notification. And so the basic components involved in Grafana for that are shown here. You define your alert rule. And this is the area I was telling you, it's obvious Grafana has really put an emphasis on this, because the last 3 releases, and especially 9 that just came out, they've really made this alert rule very robust, very visual as far as how you define them and things like that. It's really nice. So you define the rules, and then you give whatever labels to them. Obviously you can, don't repeat the rule. If this happens and this happens, if this rule has this particular text in it, you can just, whatever level, you can get down to it with the rules and the labels. And then a notification policy. And that's saying, okay, send this to Slack, or send this to whatever, which I deliberately skipped right over lab 4. So lab 4 is just showing you how to set up an alert channel, or a contact point. That's the other thing. Grafana is changing quite a bit. So they're changing the word in the console, but you won't get lost. It'll become, what's listed in this workshop is the latest as of, 2 or 3 weeks ago, which is not, it's been 2 or 3 weeks, but it was the latest at that point. But if you see alert channel and config point or contact point, it's going to be pretty obvious to you. They don't make it, they don't do those huge changes that some people do, where you can't tell what's going on. But anyway, this lab 4 was just showing how to create a Slack channel. So you just, to get alerts. And that's just a matter of, you make a Slack workshop, you get the webhook, and then you put the webhook in Grafana. So that's all lab 4 is. But you don't need, you can see these alerts within Grafana as well. So that's why list lab 4 is optional. So that's what we do in lab 5 here is first thing we do is just go ahead in and notice the perf metrics that you're going to be setting up an alert for. At the bottom of the screen for that, you see there's a tab for alert for each of these. This is where we clicked explore before. If you click edit, that's where you define what this panel is as far as what it shows, the query, the transform, and the alert. So if you click on the alert tab there, you'll go ahead and create your alert rule. So the other thing it's great about this is you can create alerts not just from metrics, but from all the types. So this Loki alert, you can say, if you see this in the log, then send an alert. So, it's all possibilities are there. So we're doing a place alert average time. And what we're doing is, again, there's so many combinations here. I just, keeping it bounded in this presentation, but this is just a very simple one. Classic condition. When the average of A, and A is the value of this place order average time, is above 0.02. Now, what's nice in Grafana is you can see what that value is currently, and we're just trying to create a test to induce this to see the behavior, right? So if you see that your green line, what's the current activity is above this, just adjust it accordingly. Because obviously I can't account for CPU times and everything in this workshop, it's not. So, but having said that, I've done the free trial a couple times, and this is where it has been. So this is probably a safe value for you. So what you'll do is define the alert with the values that are shown here. Again, saying that if the response time becomes slower than that 0.02, you're going to send the alert. And then define the other conditions. You're going to check it every minute. And if it's happened for 5 minutes, that's when you're going to send the alert. So not if it just spikes once, you're going to wait for it to be a kind of consistent condition. And then you can add additional information to the alert, like the labels I have here, things like that. And that's it. You hit save and exit. You've already set up the fact, if you set up in a different alert channel, you've already set up the fact that you're going to get alerts to that channel. Otherwise, it's just going to go to your console. And then go ahead and just run a load test to induce the condition where the response time is slower. And that's what this is saying here. This is just a curl command to run some stress. You'll see in the panel, the heart goes yellow when the condition, when the initial condition rule is hit, and then eventually goes to a broken heart red if it's been happening for 5 minutes, as we gave as a condition. And you'll either see in your console, which is the example, or I'm sorry, you'll either see in your console or in the example here, a Slack message sent to your Slack. And like I say, you can also optionally see it in the dashboard, which is what you see here, and the alerting rules tab. And there are a number of things like silences, obviously they make it convenient so you're not, if you mess up, you can go in and put it in, well, not just mess up, but if you want to silence rules or things like that, you're doing whatever maintenance, whatever the case may be. There's plenty of robust features for that in Grafana. Okay, and then just stop the load test, and you'll go ahead and see response time is slower, and then you'll get the resolved message. Okay, so with and so you can see it's pretty simple and pretty powerful to get these alerts. And I'll just show you one more example. It's just a 2-minute video here. Same idea, or 3 minutes, I should say. Same idea for, okay, very quick demo of I will use my live voice. Very quick demo of an alert rule for the case where the DQ rate is half the in-queue rate for a given period of time. Okay, and so we see that Grafana console that I showed you earlier there with the messaging information, and I induced this condition by stopping the dequeuing thread in my reproducer. Okay, and what we see here, same idea. I've created a rule. That rule says that if this, DQ rate is less than half the in-queue rate, so we're getting this for a certain period of time, send an alert notification. So I go ahead and kill the DQ, and then we'll start to see in the console live the degradation, if you will, of the dequeuing. While that's taking place, you can just take a look at some of the aspects here. You can see the subscribers. So it's really nice, just overview console for your environment. Number of DQ rates, lights in and out, the overall count. And then we see that indeed that rate starts to go down. These are some other, like I say, you can get down to the disk because Oracle exposes that through queries that you can do in the SQL. Yep. And there we see the same. That's the yellow heart, alert. It's just a pending. And then if that continues for a certain period of time, you're going to get the alert. And then that's what we see. So rather than wait for it, you see the firing and the resolved status here. Same thing as the workshop. I'm just giving one more example of that. So like I say, I'm very interested in any examples anybody else may have for us to do. Okay. And the last thing I want to do, and then we'll get to questions actually, it's going fairly quickly here, is this better understand. So this is just some instructions for when you want to take this and make modifications and play with it yourself. So very easy to do that. So the first thing I suggest is checking out the repo where the exporters exist, which is this link here. And you'll see some examples, and they kind of refer to each other. This workshop works hand in hand with the exporters, of course, obviously. And then if you want to start tweaking the exporters, what you do is go into the source here of the workshop. So this is the source that you cloned earlier. And the configuration can be found in these files for order and inventory accordingly. So it says DB metrics, but this you'll see contains metrics, tracing, and log definitions in that config. So you can go ahead and just start messing around with these files, and then just write in place issue this command. And what that's going to do is update the exporter configuration with what you just made and redeploy it. And then immediately after you do that, or within 30 seconds or whatever, you'll be able to view those in the Grafana console. And then of course you can mess with the Grafana dashboard to bring them in, create rules, etc. from there. You can also modify the application itself. And so that's talked about here. So task 3 is if you are you want to touch the application in general or specifically for tracing. But if you want to do anything with the application, they're all located under this Grafdish home. So that corresponds to the microservices data-driven Grafdish directory. So you can just go in and modify the source however you want, and then just issue this command, and that will build it, push it to the OCIR Docker repo that was set up in the setup task 1, and then it'll issue the delete command so that the existing pod deletes and a new pod with the new image comes up. So you have a full application here to mess around with and add your own microservices, whatever the case may be. But this is kind of I think a pretty handy and straightforward way to go about making your own modifications for your own use case and things like that. So with that, I'm going to pop this screen back up as far as more information.
Well, since we have a few extra minutes, I can go ahead and share the last couple of slides on the badge and some upcoming events if we'd like.
Yep. Yeah, I think so. May as well.
So if you enjoyed today's session, we do have a few more upcoming developer events, actually a couple this week, Wednesday and Thursday. But if you go to our developer.oracle.com/events, that's where all of our upcoming events will be located. And then if you do have any questions specific to the lab that we walked through, we have this email here, but we'll have the Slack as well. And then once the Zoom ends, a quick survey is going to pop up on your screen, but we have the link here too in case you miss it. But we'd love to hear any feedback that you have on today's session, as well as anything that you'd like to see from us going forward. And then I mentioned a little bit earlier today, we do have a quiz to test your knowledge on what you learned through the lab. And so that will be available at that link up there. And I will post this in the chat and Slack too. And this is what the badge will look like that you can share to your social media. I just want to say thank you again to everyone that joined us here today. Thank you, Paul, for this wonderful presentation, and I hope to see you again next time.
Thanks, Darren. Thanks, everybody.